Gotta do some negotiating here. Okay, Crewton Ramone's house of math. Doing some problem solving. Where I have an ordered pair, we'll call it a tank of water. 2 feet of water, or excuse me, after 2 hours, 15 feet of water. After 7 hours, 45 feet of water. One of them big water tanks. How much water is going in there, and how much to begin with? That pen sets? Here, try that pen. No, that one works. Ooh la la. Okay, so what scratches do these mean?
7 to 1.
Oh. 7 times 2 plus 1. Oh, I see. There you go. And what we're doing, or what he's doing, I'm not doing anything but watching, is expressing one number in terms of the other, right? And he's seeing that the most 7s that could go in there are 2, and there'd be 1 left over. But if he did 7 7s, he'd get 49, and we know that that one won't work because it's too much, right? And he just wrote it down, and we can see. Alright, so try again. So he's using, and this is, I didn't teach him this, he came up with it himself, right? Did I tell you, oh, you should use the biggest number? Or did you just figure out that that's probably the best way to try to solve these? Okay, so he's putting the biggest number in there possible, which was 6 now, and he's got
it worked.
Okay, so now give me the equation now. You are correct. I see what you did there.
Okay.
So what number did you put in there? Y equals
6.
6 x plus
1. Oh, 3.
3. There you go. Yep. Okay. So that's exactly the formula. So now using that magic formula, and we need to, I'm going to say, because you know what? Most people are not as advanced as you. And they'd never in a million years figure out how you did that. So let's use blocks and show them.
10.
What do you say?
10, yeah, 10.
I'm going to go after 10 hours. How much would be in there?
Okay, that'll be, so after 10 hours, it'll be 63.
Very good. What about, there. And then, what about at 0 hours? How much water was in the tank to begin with again?
3.
Yep, there you go. Okay. And so if I gave you a number, could you figure out the cap pen? If I gave you a number, could you figure out how many hours the water's been running?
Yeah.
How about if I said 33?
33.
So there's 33 feet of water in the tank. How long has the tank been running? Just for fun. So now he has to do some inverse functions.
30. 30 divided by 6 is 5.
Fun. How easy is this? This stuff easy.
Yeah.
Once you know how to do it, it's super simple. But this gives a lot of kids a hard time in algebra. So let's take a look at it. The first two numbers we had were 2 and 15 and 7 and 45.
So 1 was my first.
Right. That didn't work. Okay, wait. Let's get. Hold on a second. Okay, good. Wait. So you tried. Wait a minute. So it would have been 2 7s and 1 to make 15, right?
Yeah.
Okay. 2 7s and 1 works for that one, but it doesn't work for this one because 7 7s is 45. So we have to get those out. Okay. So then, happily, he went the other way. And he said, alright, so 2 6s, right? And 3. And that worked great. Okay, so then you gotta get out 7 6s. Alright? And we're gonna see that we're gonna have to turn them this way. 7 6s. 1, 2, 3. Wait, how many? Is that right?
2, 4, 5, 6.
7. You do need 7. Okay. And then 3 more. And that is representation of this number, right? Or this ordered pair. 7 times 6 plus 3 more. And over here we had 2 times 6 plus 3 more. Now watch. This is the part that's important. Okay, and actually this part, pay attention because I want you to understand it also. We don't need any more 6s. Make this cool looking. Alright, so here's this thing. Here's this thing called dy dx. The difference in y and the difference in x. Now do you see I have this thing on top of here, and what I did is I took the difference here, and you can really see, and this is a good example because it's not a square, that the difference between these two is 5, right? The total difference here is 30. Do you see this?
Yep.
Well, where's the 30? Point to it. There you go, right? So this is everything there, right? We're counting the whole numbers. The difference between 15 and 45 is 30. Now, and we just took everything off of that. Look at that. So I have, over here I have 5 times 6 minutes. Okay, so now, just being able to do that is even faster than the way you did it with the biggest, using the biggest pair, or the biggest number that'll go into both of them, is what I'm trying to say. Do you see what I'm saying? That if you just do this, watch out, watch out, watch out. If you just do this, right? In other words, if you just subtract that, subtract this over here and subtract this over here, you get that, and you automatically get the 6x, or the 6. And if you know the 6, then you can put whatever numbers in there, like 2 for example, into 6, and figure out what you need. Because 6 times 2 is only 12, so you needed 3 more. 7 times 6 is only 42, so you needed, over there, so you needed 3 more. Alright, so I'm going to give you another one, and try doing it that way. What do you say? Okay? Alright. Alright. We are in fact recording. Here, erase that and below you. Right, this. So what we have here...
With what?
With that. How's that? What we have here is another ordered pair. 3 and 16. Oops, where'd the pen go? Here, you have the pen. So 3 and 16. Right? After 3 hours, there's 16 feet of water. After 8 hours, there's 31 feet of water. What do I got to do? There you go. See, now he's doing dy dx. And what are we doing when we do dy dx? We're finding the rate. So, can it be?
Yeah.
You sure it's 25?
Mm-hmm. Minus the 1 equals 5.
How'd you get 31 minus 16 is 25?
Oopsie.
That seems like an awfully big number there. So you have to be able to do math, you know, in order to do the problem. You have to be able to do the simple mathematics. So what is it? It's not 5.
It's negative.
What is it? It's not negative.
Mm-hmm.
What is it? 31 minus 16. It's going to be 5. The 5 is going to be there.
Yeah, 31 minus 16.
Mm-hmm. We're trying to find the rate here. Could be a donut factory. After 3 hours, there's 16 cases of donuts. After 8 hours, there's 31 cases of donuts. How fast are they making donuts per hour, and how many donuts were in there to begin with? How many cases? But first,
20.
Just subtract. It's a simple subtraction.
Oh, 2.
You're telling me you can do. How is
wait,
it?
no. Yeah. Wait, no.
Well, look at it another way, you goofball. What do we have to add to 16 to get to 31? If you can't subtract 16 from 31. Cap your pen. We'll wait. Really, so simple subtraction is thwarting you. We have it on video.
I know. It's a 10, 15.
He said, there you go, so why don't you write it down? 15 is correct. Okay.
3.
So 3. So now we know the rate is 3. They're making 3 per hour. So what would it have to be? If they're making 3 per hour, is that true? Oh my goodness. So 3 times 3 is what?
No.
So write it down. Y equals 3x. Write that down. Okay, so now we got that much. Now, y should be 16. So after 3 times 3 is how much? No. There you go. Does it work for that one too?
Yeah.
Does it?
Okay.
Tell me.
8.
8 times 3 is?
8 times 3 is 24.
Yep. Plus 7 more.
7 is 31.
Okay, so in our donut factory story, at 0 hours they started off with how many cases?
Oh wait, no, 3.
0 hours. How many?
3.
How do you get 3? That's the rate.
Okay.
There we need to see. There you go. We need to know. After this is my constant. In other words, I started with 7, and every time you're going to have 7 there. And that is my rate. So now, could I graph that? Of course I could. Would that be easy? Yes. And the simple formulas that they give children never help them do this. That y equals mx plus b and the dy dx and so forth. Well, here we really see the dy dx. And we can get the, what do you call, the blocks out to actually model it and show what's going on there. Okay, and then pretty soon, once they understand that all you do is take the difference of these two and put them over each other, y1 minus, right, what is it, y1, the difference of y's would be y2 minus y1 and x2 minus x1 to give you the rate divided by each other here, right? So it makes sense. They can see it. They can see why it is. I had a kid in here that just got the formula, and that formula didn't help. Okay, what else could we do? We could show a quick model of this. Well, let's stop the camera and make a model. Alright, so here's what we have. There's the model of them. 3 3s and 7, 8 3s and 7. And then we can really see, we take the difference there. There is the difference there in x, so we can see that these are x, right? That's your change, right? So there's my difference there between 8 and 3, which is 5. And there's my difference there, which turned out to be 15, not 25, not 5, but 15. And of course, if the whole rectangle is 15 and one side's 5, the other side must be 3, which gave us our rate. And then here we have our constant, and that gives us this simple formula, right? So we can start figuring out what goes on. And then we can fool around with you know, negative numbers like these. Now that we understand the concepts, we could make it so that we could graph or make an equation for any 2 points. Okay, Crewton Ramone's House of Math.com for more. Okay, so one, we're building a house, which is again just practicing more add-ins, right? Which you can never practice too many add-ins. And at the same time, solve this problem for me. 7x plus 4 equals 3x plus 20. What is the answer? What is each x equal to? So could you draw it, or set up your blocks, or use a pen, or what are you going to do? How are you going to solve it? Remember? Find same on both sides.
Yeah, okay, fine, then I'll use a pen.
You use a pen? Where's your pen?
The red one.
Yeah.
Where did it go?
Okay. Okay. So what do we got to do? Here 0, no fun, get back to 1, right?
Yes.
Okay.
7x.
I'll be interested to see.
Okay. Minus 7 over here.
You can't. Can you take 7 away from there?
Minus 3 over here, so that makes it
3x, not just 3.
Yeah, x.
You can't just take away 3 from 3x.
And then you got a minus over here.
Mm-hmm.
Oh, oops. What the heck was that for?
I don't know. Making a nice mess though. 3x.
Yes.
Right. So how many x do you have if you take 3x away?
I have 4x.
That's right. Alright, so then what? Got some other stuff getting in the way here.
Plus 4.
Yeah, so what do we get rid of the 4?
Minus 4.
Yeah.
Minus.
Now see, a lot of kids will want to try and do that. Is take away 3 from 3x. You can't take away 3 from 3x. You can only take away 3x from 3x, or more x. Okay, so you got a 0 there, but you got to take it. Don't forget over here.
Yeah.
Taking the same stuff, right?
4.
Is that a 0? Is 20 minus 4 0?
Oh my god.
You're just having fun. I know. Oh my gosh, he's right. Just, it's fine. Just write it. Write down 16. Okay, and we need an equal sign. Over here would be good, probably.
Sorry.
Alright. So now we've got 4x equals 16. Yeah, we don't. Yeah, that stuff just gets in the way now. We know it's 0. We know it's 0.
4x equals 16 divided by 4. 16 divided by 4.
Yep.
Yep. See, I'm so smart.
Yeah.
6. Then we go.
Smart and humble is always a good way to be when you're a mathematician.
16 divided by 4.
Oh, Jess, what is it? There he is writing it out. How about if I put a line over here?
4.
Correct, you are. So just write x equals 4. Well, the cap ran away. Okay. So here, put a line there and put 4, because that's what you divided by, 4, right? And then over here, put a line and divide by 4. So now we divide both sides by 4, and we see that x equals...
X equals 4.
There you go.
Woohoo.
Alright, fine job. Oh, wait, we're not done. If we put 4 in each one, what are the numbers that are equal here?
Okay.
In other words, we had 7x plus 4 and 3x plus 20.
Okay.
Where's it going to be?
I put...
In other words, put the 4 back in for x. Because we know now, 7 times 4 is...
7 times 4 is 28.
There you go. Plus 4.
Plus 4 is 28 plus 4. Oh, it's 32.
There you go. So this side better be 32, huh?
Yep.
So let's check. What's 4 times 3?
12.
Plus 20.
Oh, 30. Oh, 30. Wait, no. 32.
Yeah, there you go. So it works out. 32 equals 32. There you go. No blocks on this one. Understanding the rules because, like I said, the student is a little more advanced. But did we start off with blocks? Would we start off taking away these and taking away from when we start off with this? Yes, that's how we started. And then we did move to some pictures. We could draw some quick pictures.
7.
And then we moved to symbols only. And do you see how basically this makes it so that you have to be able to do multiplication and addition and subtraction and so forth in your head easily and quickly? That's why we practice all the other stuff, so that you can do some problem solving using your mathematical computation skills. Alright, Crewton Ramone's House of Math.com for more.